Hello students, welcome to today's session. So in this session, we are going to see about IoT platforms and design methodologies for IoT level 4. So far we have seen 3 IoT levels. So in that 3 IoT levels, the system has only single node. So but in its 4th IoT level, so which has multiple nodes and performs local analysis. So we are going to see in detail. So these IoT levels which has the system comprises of devices, resources, control services, and then a database, web services, analysis components and application. So devices, the IoT device allows identification, remote sensing, actuating and remote monitoring capabilities. So resources are software components on the IoT device for accessing, processing and storing sensor information or controlling actuators connected to the device. So it includes the software components that enables network access for the service and also the device. The controller service is a native service that runs on the device and interacts with the web services. So controller services sends data from the device to the web service and receive commands from the application through web services for controlling the device. So database has the storage of data, so which is generated by the IoT device, which can be either stored locally or in the cloud. So web service serves as a link between the IoT device, application, database and analysis component. So it can be implemented using HTTP or REST principles or using WebSocket protocols. So analysis component is responsible for analyzing the IoT data, generate results in the form which can be easily understandable to the user. So analysis of data can be performed either locally or in the cloud. So analyzed results are stored in the cloud and cloud database. So applications, the IoT applications which provides an interface that the users can use to control and monitor various aspects of the IoT system. So application also allow users to view the system status and view the processed data. So in this part we are going to see about the IoT level 4. So level 4 which has a multiple nodes. This system has multiple nodes that perform local analysis. So the data which is stored in the cloud and the application is cloud based. So the user can interfere with the cloud storage with the application. So level 4 contains local and cloud based observer nodes which can subscribe to and receive information collected in the cloud from IoT device. So the data which has local and cloud based observer nodes. So the device having the particular nodes which can subscribe to the data server with the help of cloud. Okay. So and then level 4 IoT systems which are suitable solutions for where the multiple nodes is required. So multiple nodes where whatever the system require, it can be used. Okay. So the data involved is big and the analysis requirements are computationally intensive. Like level 3, the computational intensive data is much more required for the both systems. So in level 1 and 2, the data is processed locally and also stored in the cloud. So the level 1 has more less number of data handlers. So data handling part is more less. Okay, the data which is processed is compared to level 2, level 3 and level 4 data processing is very low. So that data which is required is also very low in the first level. So level 4 and level 2 and level 3, so which has more number of data processing. But level 2 which are not having computationally intensive data. Okay, the analysis part is not computationally intensive. But in level 3 and level 4, the analysis requirements are computationally intensive. So far we have seen from the tracking package handling and also smart irrigation. So we are going to see that in detail. So this is IoT level representation. So which has multiple nodes. So the monitoring nodes. So which has to perform local analysis and through the cloud storage. So this having the device which is sensors included with microcontrollers, and the resource, which is a software component, and the controller service, so which is the native service, which can be connected to the REST services and to the app. Okay, so it has multiple nodes, that is observer node, and then a database which having collection of data. So through this the controller service which is connected to the app with the help of a REST service. So here the analytic and complex component part having a IoT intelligence. Okay, so and then this is the local node observer node, and this is the cloud observer node. Okay, so where the data processing is high, the multiple data can be involved, and it is computationally intensive. So we are going to see the one example with the noise monitoring. So this noise monitoring is important in the environmental application. Okay, so the increase in noise levels in cities are due to factors such as people's migration to big cities, the impact of transport and traffic, and building works, industries, and outdoor and nightlife activities such as concerts and festivals. So this makes noise pollution. Okay, so one of the biggest problems. Okay, so this makes noise pollutions that worries citizens and public administrations. Okay, smart and more efficient systems are required to offer that is more than sporadic monitoring of noise levels with technical devices. So these noise levels are we can't calculate. Okay, so the noise is happening particular time, or so at any time it can cause. It is a irregular activity. So the solution of continuous noise monitoring enables public administrations to know in real time the levels of noise and the areas that concentrate the highest levels, so that the local policies for the prevention and reduction of noise can be established. So the composition of noise monitoring solution. The solution for monitoring environmental noise in smart cities, which includes sound level monitor, system for data collection, that is data logger, control center for data reception, and then information platform. So monitoring noise in real time. So the network is established throughout all the strategic points in the city, so that the sensors can monitor the level of noise pressure in the environment continuously, that comes from construction noise and workplace noise. So our the services, okay, the wireless device which enables a quick, economical, and flexible display for monitoring and managing noise pollutions. So the equipment is a complement for multi-purpose weather station or two. Okay, so the noise monitoring systems can be installed outdoors on a street light or directly on the wall. So it includes a damp-proof microphone and a protective cover to shield it from the elements. So the communication modules like 3G, 4G, and LoRa long-range communications are used. So data displays, display and analysis part. So this is integration with the wireless communication modules. The measurements are transmitted to the IoT platform to monitor the noise were once registered. So they are available in real time by means of users applications. So the database which receives and stores the data related to noise from terminals and from each sensor. So that is sound level sensors, and it does the most monotonous and repetitive task. So the time-based recalculation, day or evening or night calculation, and analysis of incidents, a comparison with regulatory limits, email alerts, data download, and creation of reports. So these are possibles in the noise level monitoring. So it display and analysis systems. What are all the components which are to be displayed means monitor the evolution of noise levels in the city. So and to analyze the efficiency of measures against noise pollution. So improve supervision in the areas with the highest levels of noise, and access compliances with the noise levels established in the legislation. So provide information to conduct research on noise, and also to develop action plans against environmental noise to guarantee the citizens' welfare and satisfaction, and are efficient local strategies adapted to the real situation of noise pollution in each area. So foresee possible complaints from the neighbors and information activities for citizen awareness. So the warning system, which includes the solution for noise monitoring, which enables the generation of warnings to notify in real time. So in real time, WebSockets are used. Okay, so in order to communicate, provides a bidirectional communication, that is full duplex communication. and when certain levels of noise have been reached. So public bodies can then take immediate action to revert the situation. So the clients which have a platform at their disposal to see different noise indicators, percentiles, and indexes that can become useful information. Okay. So it is possible to create reports with a regularity defined by the users of the system, so that they can get a real photograph of the situation and thus define action plans about the acoustic comfort. Okay, this includes the noise monitoring. So the advantages of using this noise monitoring solution. So it is a open solution and integrable with external developments at any level. So that may be a device level or cloud or user application level. So multiple devices can be included in the future extensions. So multiple unlimited number of devices which can be included in these extensions. So high reliable and available data in real time. So this is a most important one, and it has a tailored systems. So creation of a data history for public administrations are possible. So these are all the advantages of IoT level.